Aloha and welcome. In this lesson, we're going to be talking about two simple concepts, break and continue. Both of these are used within loops and they both do something a little bit different. Break is going to knock you out of a loop altogether, and continue is going to actually knock you out of the current iteration that you're in within the loop. It's not going to exit you from the loop itself, but it'll actually stop your execution within that one iteration. So you're going to go back up and start over at the top of the loop again. So I will show you what the book used for the examples on this to kind of explain it. And if you weren't following along very well with the code examples, I don't blame you. They're a little bit involved for explaining these simple concepts. So let me try to explain it a little bit better. So we're going to look right now at VS Code. We're going to take a look here at the example program they had. So the idea is that you have empanadas and tacos, and you're going to let the user input how much money they've got for the meal. And then you're going to find out, okay, what's the max number of empanadas you can have? So they're dividing the user money by the empanada cost and throwing out the remainder there. So you can't have like 5.2 empanadas, so it's going to just say 5. So the same for max tacos, you divide the money that you have by the taco cost. So that's the max number that you could go to there. So we start out by initializing the meal cost to 0. Now we set up our first actual loop here. And right after that, we're going to have our secondary loop. So primary loop is on tacos. We are essentially saying that tacos take the first priority here. So we're going to start with one taco, then we're going to start looping empanadas. And we're going to go, the range is, because we only have one argument here, we're starting at 0 and we're going to the max number of tacos plus 1. Because when we're doing a range, the max tacos, if we just put max tacos here, it would go up to max tacos minus 1. So you have to put that plus 1 in here to make it go all the way up to max tacos. Then we do the same thing for the number of empanadas. And then after we start the loop here, we're going to come across meal cost. So the meal cost for empanadas, you're going to have the number of empanadas times the empanada cost. Then you're going to add to it the number of tacos plus taco cost. So on the first iteration here, we're going to have tacos is equal to 0. So we're going to have 0 tacos, and so 0 times the cost is going to be 0. We're going to add that to 0, so we should get a bunch of 0 here. If the user money was 0, we would break out. Otherwise, we would continue on. So after we finish going through all the empanadas, we're going to look and see if the meal cost is equal to the user money. If it was, we're going to break. We're not going to leave the 4. But the reason we have this here, the reason that we have this meal cost equals user money is we're trying to see that on this iteration, we have a certain number of tacos. When we add that extra empanada, we're trying to calculate, did we just use up exactly the amount of money that we have? If we do, there's no more sense in going through all of this, because we know that adding on a taco or an empanada is going to put us over the amount of money that we have. So it doesn't make sense to continue. And that's why we have a break here. The break allows us to kick out of here altogether and go to the end of this for loop. So we're not going to do any more iterations of it. We're going to knock out, we're going to go down here. And then you see this again, if meal cost equals user money. So what happens here is we're evaluating it because if it is, we don't need to add tacos anymore and go through tacos and empanada combinations. So we want that second break here to knock us out of this loop. Then we knock out of the loop. Then we say, is meal cost equal to user money? If it is, then it's going to tell us, that amount of money buys you how many empanadas and how many tacos without change left over. If it doesn't, then you're going to say you can't buy a meal with, without having change left over. So this entire thing, you're probably wondering, why exactly are they doing it this way? Why didn't we start with empanadas over tacos? Why is it that we're only choosing the first meal option here that gives us that, because there may be multiple ones. Maybe 2 tacos and less empanadas will, give us the same thing, but they're only looking for that first one. And they don't really explain that they're only looking for the first one, except in this comment here. So people may have gotten confused. But what they're trying to tell you, what they're trying to show you essentially, is that there are times when you want to break out of the loop altogether. So this loop will knock you out of this, or this break will knock you out of this loop here, and this one here will knock you out of the bigger for loop. Now I'll put you down here, and you can see if it's, if your meal cost does equal user money. If so, it's there. If not, that means you've gone through all these different combinations and meal cost didn't equal user money, and you're going to say you cannot buy a meal without having change left over. So yeah, it's a very involved example, and it's only there to show you, first of all, the break, and also why. And the why of it essentially is, once you get to a certain point, there's no sense in going through all the rest of them. So if you're doing something, you're checking like let's say a number between 1 and a billion, if you already know at number 5 that, you've got your answer, there's no sense in going out to the billion. You can greatly reduce your time processing by just short circuiting and saying, okay, we got it, break out. And it's the same down here. So you can break out of your thing. Sometimes though, you don't want to break out of it altogether. Sometimes you just want to go to the next one, and or the next iteration of the loop. And that's what we'll work on next. So we'll comment out this code, and we'll look at the second demo that they had in the textbook. So here we start with the empanada cost of 3 and the taco cost of 4. We're saying we're getting the user money and the number of diners. Now, for some reason, they want that when you do find your max number of empanadas and tacos, no longer are they just going to take the first combination, they're going to take them all. But there's a twist. They also want that number of empanadas and tacos added together. They want it to be evenly divisible amongst the number of diners that are eating. So that's another added wrinkle to it. So we start off by initializing our meal cost and our number of options. And we say number of tacos in range. We've already talked about that. Number of empanadas in the range. So then we're going to go down and it says total items purchased must equally be divisible by the number of diners. So what we're going to do here is we're going to take a look. We're going to say if the number of tacos plus the number of empanadas is not evenly divisible by the number of diners. In other words, we're using the percent here, which is modulo. So modulo is really looking for the remainder. So you take the total of this, you divide it by the number of diners, and it's looking at the remainder. If the remainder isn't 0, we know it's not evenly divisible. So whether or not the empanada cost and everything else adds up, doesn't matter. So we're going to kick out and we're going to go up to the next iteration. We're going to add another empanada in there and see if that makes it evenly divisible. So we just keep on going through this. And if we do hit a situation where the number of tacos and the number of empanadas are now evenly divisible by the number of diners, then we're going to go down here. We're going to say meal cost is equal to the number of empanadas times the cost plus the number of tacos times the taco cost. Then we're going to say, hey, is the meal cost equal to the user money? If it is, then we're going to print out that, hey, that meal cost buys X number of empanadas and X number of tacos without change. And then we're going to say that the number of options is the number of options plus 1. So what we're doing is we're trying to count the number of actual combinations that we can have here. So once you finish this, once you get through all of your different loops here, you're going to have printed at each one, you'll have printed out what your options are, and you'll also be keeping track of the number of options you have. So maybe you find something that's you have it evenly divisible by the number of diners like 5 times and it adds up. Then at the end of it, you'll have 5 print lines that show you what the different things are. And then you'll come down here at the end of it, you'll say, is number of options equal to 0? And if it is, it's going to say you cannot buy a meal without having change left over. So you could also put an else here and say, else, you have plenty of options, or you have number options, because you've counted the number of options. You can have it say you have 5 or whatever that number is. So that's demonstrating the continue. So the idea is basically, you get up to here, you don't want to kick out of the for loop altogether because you still want to process each one. But we already know that since it's the number of diners, when you add to the number of tacos and the number of empanadas, it's not going to actually be evenly divisible there. So it says now, just don't even bother, let's continue. Let's go up to the next iteration. So then you go to the next number of empanadas and you check that again. But all they're doing with this big grand example is showing you this continue function. Just know that continue is going to knock you out of not the entire loop, it's just going to knock you out of this iteration. In other words, continue is going to say, don't run this stuff here. Just go back up here and take the next one and then run through everything again. That's all the continue does. If it was a break, remember, it knocks you out of this entire for loop altogether and it goes back up to the previous one. So I know this is a little bit hard to grasp. Honestly, it's a simple concept muddied by these complex examples. The reason I have the complex example is to show you the why of why you want the continue or why you want the break. But it's a bit of an involved example, if you ask me. So just keep in mind, this is the important thing here. The break knocks you out of the loop altogether, and continue knocks you out of the iteration, just the one time you're going through it. So if you have any questions about this, if it's a little bit less than clear, feel free to reach out to me. I'd be happy to talk to you about it. I'd be happy to show you some code examples and walk through this with you. But that's essentially all that we're going to be talking about in this lesson. Reach out if you need help. Otherwise, I'll see you in the next video.